Hello, and welcome to this podcast for radiation physics at Wenatchee Valley College in Wenatchee, Washington. I am Todd Bussey, your instructor, and I hope you find this podcast and all the other podcasts for this class helpful. In this podcast, we will be discussing exponents. So let's look at the first example. First of all, we have to look at what an exponent is. What an exponent is, we have a to the fourth, and what that means is we have four a's multiplied together. So we have a times a times a times a. So whatever number of a's that you have multiplied together, that's the exponent that we have. We could have x's, we could have 2, whatever the number that we have of those numbers or letters, that's the exponent that we have. Now we have a bunch of rules for dealing with exponents. There's 8 of them. The first one is if we have a to the m times a to the n. You'll notice that the a and the a are the same. That means the bases have to be the same for this to work. We could not have x to the fourth times y to the fourth. We cannot add those exponents together. So when we have that, a to the m times a to the n, we add the exponents together. We get a to the m plus n. So our example is x cubed times x to the fourth. The x's are the same, so we take the exponents, the 3 and the 4, and add them together. 3 plus 4 is 7, so we will get x to the 7th. The other way to think about that is when we have x cubed, we have 3 x's. When we have x to the fourth, we have 4 x's. So to get all together, we have 7 x's. So since we have 7 x's, that means it's x to the 7th. The second rule that we have is if we have a to the m over a to the n. So we have a fraction. When we have a fraction, we subtract the exponent. So we're going to have a to the m minus n. So we have the top minus the bottom. In our first example, we have a to the 9th divided by a to the 7th. And we're going to take the exponents and subtract them. 9 minus 7 is 2. So we're going to have a squared as our final answer. Now another way to think about this one is similar to what we did with the multiplication. If we have x to the fourth over x to the 7th, the x to the fourth means we have 4 x's on top of the fraction. The x to the 7th means we have 7 x's on the bottom of the fraction. If we have x over x, x divided by x is 1. So each time we have an x on the top, we can wipe out or cancel out an x on the bottom. So in this case, the 4 x's on top wipe out 4 x's on the bottom, and we'll have nothing on top. Well, we can't have nothing on top. We need a placeholder on top, and it's going to be a 1. So we have 1 over, well, we have 3 x's, so we're going to have x cubed on the bottom. So our final answer for this one is 1 over x cubed. We could do it the same way as we did the subtraction. 4 minus 7 is a negative 3, and later on we'll find out that the negative means we put it on the bottom of a fraction. The third rule we have is we have the quantity a times b, all of that to the mth power. And when we do that, we just distribute the m through the parentheses to the exponent of each of them. So we have a to the m times b to the m. So in our example, we have xy, all of that raised to the 7th power. So we bring that 7 into the parentheses, and we'll have x to the 7th and y to the 7th. The next example is we have 2x, that whole quantity, raised to the 4th power. So we bring the 4 in, and we're going to have 2 to the 4th times x to the 4th. Well, 2 to the 4th is 16. 2 times 2 times 2 times 2. And x to the 4th is x to the 4th. So we will have 16x to the 4th on that one. The next rule we have is a fraction rule. A over b, that quantity, raised to the mth power. And we do the same thing we just did. Bring the m in, but we're going to bring it in on top and bottom. So we're going to have a to the m over b to the m. And now we cannot have b being 0 because we cannot divide by 0. So our one rule that we have, one restriction that we have on this one is b cannot equal 0. So let's look at the first example. We have 3 over x, that quantity, to the 4th power. So we're going to bring the 4 into the parentheses, so we'll have 3 to the 4th over x to the 4th. 3 to the 4th is 81, x to the 4th is x to the 4th. So we'll have 81 over x to the 4th. Our next example is we have y over z, all of that raised to the 3rd power. So we're going to have y cubed over z cubed, and we can't reduce that at all. The fifth rule that we have is we have a to the m on the inside of the parentheses, all of that raised to a power. So the way I like to think of this is a power raised to a power. When we have a power raised to a power, we multiply the exponents together. So we have a to the m times n. In our first example, we have x cubed raised to the fourth power. So we have x to the 3 times 4 power, which is 3 times 4 is 12, so x to the 12th power. Another way to think about this is we have 4 x cubes that we're multiplying together. And each x cubed means we have 3 x's and we have 4 of them, so we have 12 x's total, so that's x to the 12th. Same idea goes with the 2x squared, all of that raised to the 4th power. Bring the 4 into the parentheses, so we'll have 2 to the 4th, and we'll have x to the 8th, because 2 times 4 is 8. And 2 to the 4th, as we did before, is 16, so we'll have 16 times x to the 8th. The sixth rule we have is the rule of 0. When we have a to the 0 power, that is 1. Anything to the 0 power is 1, as long as a does not equal 0. 0 to the 0 power doesn't make any sense, to mathematicians at least. So we have 4 to the 0, that's going to be 1. Y to the 0 is going to be 1. 6x squared, that whole thing to the 0 is going to be 1. Anything to the 0 power is going to be 1. So anytime you see something to the 0 power, make it a 1, and you're done with that. The next one is dealing with negative exponents. We have a to the negative n. What that means is since it's a negative exponent, we have to put it on the other side of the fraction bar. In this case, it's on top. We're going to put it underneath the fraction bar, so we will have 1 over a to the n. As long as a is not 0, because we can't divide by 0 again. So our first example on this one is we have x to the negative 4. We want it to be a positive exponent, so we're going to have 1 over x to the 4th. The next example is 4 to the negative 3rd. 4 to the negative 3. We want the negative 3 to be a positive, so we have to put it on the opposite side of the fraction bar. We will have 1 over 4 cubed. 4 cubed happens to be 64, so we will have 1 over 64. If the negative exponent is on the bottom of a fraction bar, we just have to put it on top of the fraction bar, which is our last example for exponents. So 1 over a to the negative n. It's a negative exponent. We want it positive, so we put it on the other side of the fraction bar, which means in this case we put it on top, so we'll have a to the n. As long as a is not 0, because we cannot divide by 0 in the original expression. In our example, we have 1 over x to the negative 2. It's a negative exponent. We want it positive, so we put it on the other side of the fraction bar, and we'll get x squared. In our second example, we have 2 over 3 times 3 times x to the negative 2. The 2 and the 3, the exponents are positive 1s, so we don't change those. But the negative 2 on the x, we need it to be a positive exponent, so we put it on top of the fraction bar. So one way to write the answer is 2 times x to the second over 3, or we could write it as 2/3 x squared, as long as we realize the x squared has to be on top of the fraction if we put it that way. Our last example on this podcast is 2x to the negative 3y over 3z to the negative 2r. So the 2 and 3 have positive exponents. They stay where they are, the 2 on top, the 3 on the bottom. The x has a negative exponent, so that goes on the bottom. The y has a positive exponent, stays where it is. The z has a negative 2 exponent, so that's got to go on top. And the r has a positive exponent, so it stays where it is. So our final answer on that one will be 2yz squared over 3x cubed r. And I just put them in alphabetical order on top and bottom. You don't really have to, but you can. So that concludes this podcast on exponents, and we will see you next time. Thank you. Bye.